Just recently in class, we discussed with you the type of orthogonal maps, which are a combination of rotation and reflection. This is the example of this type. We had this matrix, which we determined was the rotation combined with reflection. We found out the axis of rotation and the plane of reflection, and we found the angle of rotation. Right now, in this short video, I will make the video demo of actual action of this map given by this matrix Q. Okay, so for that, to that end, what I will do, I will use this web app, and on this web app, you can see I already constructed the plane of reflection. This is a blue halo you see, and this black vector. This is a vector of rotation. So what I will do now, I'll take this triangle, this purple triangle, and I will show you how this map acts. First, I will show you the action of the original Q matrix or original Q map. What it does, look at this. What it does, this purple triangle represents the gradual connection between the original triangle and the image of that triangle under the Q map. See, we sort of rotate a little bit and reflect at the same time. We rotate and reflect at the same time. This is a combined action of the Q map, combined action, where rotation and reflection, they are mixed together in a continuum of action. Now, I'll fix this endpoint position. This is the final action. This is the final point, or that's where the triangle will be, where Q map from here acted on it. And now I will show you how this splits into two separate actions. So to that end, let me just open this and run this play. See, this is the action of rotation alone. If I arrange my plane or arrange my view in a way that my black vector, this black vector disappears into a point, this is the axis of rotation. So we're now looking, we're now looking perpendicular to the plane of reflection. Now you can see the pure rotation. And at the end point, you see my triangle matches the purple one on the other side of my plane. This is the rotation alone. So if I pause it now and I take it to the end point of this rotation, now if I start the reflection, you will see how this rotated triangle is taken to the endpoint by the pure reflection. This is the second stage of my Q action, rotation combined with reflection. Rotation combined with reflection. So once again, this is my initial position. This is my initial position. Perpendicular. We're looking perpendicular to the plane of reflection. First we rotate, and then we reflect. In fact, you can do it in the other order. You can first reflect and then rotate. This will be the manifestation of the fact that our rotation and reflection, they commute. So look at this. I can first reflect. This is a reflection, pure reflection. Pure reflection with respect to my reflection plane. Because we haven't done the rotation, the result of the reflection doesn't. Because we haven't done the rotation, the result of the reflection doesn't match the triangle on the other side. But now if I fix it, if I fix the action of reflection, here it is, on the other side of my plane, Again, if I arrange my view that I see my rotation axis from the top, now if I start my rotation, you will see how they will match eventually by the rotation law. 1. So this example actually tells us that by splitting into the rotation and reflection, these two individual actions, they commute. It doesn't matter in which order you apply them. You can first reflect and then rotate, or you can first rotate and then reflect. Either way, you will end up with the same result. That's the end of my demonstration. Thank you very much.